Hi guys, welcome to lesson 1.3. In this lesson, it is all about transformations. So to get started with this lesson, we're going to start right here by filling out this chart. This chart is your key to all things transformations. So let's start with this. First off, if you have anything happening outside the function, so let me give you some examples. Here's a square root function. If I am adding something to the outside of the square root. Or here's let's do an exponential. Here's 2 to the x. If I am multiplying outside that exponential. Or give you another example. Here's a rational. If I subtract 5 outside that fraction. Those are all things that are happening outside the main function area. That's what I mean when I say outside. Now, if there is anything happening outside, it is always going to move the graph up and down. Always. So sometimes it shifts the whole graph up and down. Sometimes it stretches or squeezes the graph wider or skinnier. Sometimes it reflects the graph up and down, but everything that is outside is affecting the graph vertically, up and down. Another thing to note, and we'll talk about this one more later, is it always affects the graph in the same way you think it should, meaning it's kind of intuitive. Now, if things are happening inside, so let me give you some examples. We have our square root. I am subtracting something inside my square root. Or I have my exponential. I have something happening up inside the exponent. Or I have my fraction. I have something happening inside that fraction. Right down there. So that is what I mean by inside. Now, if something is inside that function area, it will always affect the graph horizontally. Always. So move the graph side to side, stretch it side to side, reflect it side to side, all those different things, but it will always affect it horizontally. And it will always affect it opposite what you think it should. And I'll talk about that more in just a second. Now, we have 3 types of transformations that we talk about. The first one we talk about is a shift, also sometimes called a translation. A shift or a translation happens anytime you are adding or subtracting a number. So if I come up here to these examples that I did, that would be a shift because I'm adding or subtracting. That would be a shift because I'm adding or subtracting. Adding or subtracting, adding or subtracting. So all those green ones would be shifts or translations. The next one we'll talk about are scalings. And these ones are also called stretch or shrink. So if you think about your parabola from secondary math 2, it'll either make your parabola way fatter or way skinnier. That's a stretch or a shrink. And scalings always happen when you are multiplying. So if I come up here and use some blue, I'm multiplying 1/2. So that's a scaling. I am multiplying by 2. That's a scaling. So anytime we're multiplying, those are scalings, multiplying by a number. The last one we have are reflections. And those happen anytime you're multiplying by a negative number. So, give you an example, if I have this square root, and then I multiply by a negative outside. So now it's negative square root of x. That would be a reflection. You can also multiply inside. That's just going to reflect it a different direction, which we'll talk about more in just a second. So, now that we have our 3 types, let's go in depth more. Let's start with a reflection. They're actually the easiest. So let's do the example we're going to be working with for this entire chart is up here. Our parent graph is y equals square root of x. So we're going to very quickly just draw what the parent graph of this looks like. 1, 2, 3, 4, 5. Oops, I want 9 actually. 2, 3, 4, 5, 6, 7, 8, 9. Now, points on this. So I plug in 1 here. The square root of 1 is 1. So 1 comma 1 is one of my points. Square root of 4 is 2. So 4 comma 2 is one of my points. And the square root of 9 is 3. So 9 comma 3 is one of my points. If you don't remember what that parent function looks like from last class, that's how you can get it again. Hopefully you're starting to get those memorized though. So that's our basic parent graph, y equals square root of x. So if we come down to our reflections, I can have a reflection that is outside. This is my outside column. Or I can have a reflection that is inside. And notice that the difference is where the negative is, outside or inside. Now, remember, we have said that outside is always up and down. So I'm going to sketch out my original parent graph with a dashed line. That's what the parent graph looks like. If this is outside, that means it will reflect up and down because outside is always up and down. So it's just going to take all of my points and reflect them across the x-axis, aka reflecting them up and down. So this, ooh, that was wonky. That will be what my new graph looks like. So this right here is the graph of y equals negative square root of x. Now, you may already have a guess if we have a negative inside. Well, we've already said that inside always reflects side to side, or always does stuff side to side. So if this, once again, is my original parent graph, and I have a negative on the inside multiplying by a negative, I'm going to reflect everything across the y-axis, side to side, because it's inside. So I take all these points, reflect them across, and that is what my final graph looks like. So this is the graph of y equals square root of negative x. So that's our reflections. Now let's go to the next easiest one, which is our shifts. We're going to start with our outside shifts. Now remember, outside is always up and down. The reason there are 2 boxes here is because we have adding a number and subtracting a number. Those are our 2 options for shifts. Now, it's pretty intuitive. Remember, outside is always up and down. So if you add a number, it's going to shift the graph up. Whereas if you subtract a number, it's going to shift the graph down. Now remember, this only works if the numbers are outside the square root. So let's do, for adding, let's add 1, and subtracting, let's subtract 4. Notice that both of this adding and subtracting are outside the square root. So that means if I have my original parent graph, I'm going to do it in dashed lines again. I'll do it over here too. Original parent graph in dashed lines. This, because it is adding on the outside, means I'm going to shift that whole graph up 1. So shift all these points up 1. And you'll notice that's just changing the y value of all these points. The x value stays the same. It's just changing the y value. So that is my final graph that has been shifted up 1. Now, same thing, I have over here a minus 4. It is a subtracting outside, so that's going to be shifting the graph down 4. So we'll take all these points and move them all down 4. And that's my new graph. Okay, let's talk about inside. So these are, again, adding a number and subtracting a number. But now I'm adding and subtracting that number inside the function. So for our adding number, let's add 2. For our subtracting number, let's subtract 3. So notice that both of them are inside the main function area, inside the root. Now, we know that inside always moves left to right. So you might think that adding should move to the right because that's the positive direction on a number line. So adding should move to the right. Except inside is always opposite. It's counterintuitive to what you think it should do. So adding a number inside is actually going to shift the entire graph left. Whereas subtracting a number inside will shift the entire graph right. So here I'm going to draw my original parent function in dashed lines on both of these again. Okay, this is adding 2 on the inside. So adding on the inside means I'm going to shift the entire graph left. So I'm going to move all these points left 2. Notice that this moving left is only affecting the x values. The y values are staying exactly the same. And over here, I'm subtracting 3. So I'm subtracting a number on the inside. So that means I'm going to shift the entire graph right. 3. So it's going to look something like that. And those are our shifts. The last one we need to do are our scalings. And then we'll be done. We can start to move on to some examples. Scalings happen when we are multiplying by a number. Now, there are 2 types for this one too. Just like with shifts, we had adding and subtracting. For scaling, we can multiply by a number greater than 1, or we can multiply by a number between 0 and 1. So think of a number bigger than 1, or basically like a fraction between 0 and 1. Now, we don't worry about negatives because that's a reflection. And multiplying by a negative is a reflection. So those are our 2 categories here. We can multiply by a number greater than 1 or multiply by a number between 0 and 1. Now, let's talk outside first. Outside's always easier because it's the same. It's intuitive. And since we're outside, we are multiplying by a number outside our function area. So this one has to be greater 1. Let's do 2. Multiplying by a 2, greater than 1. This one has to be between 0 and 1, so let's multiply by 1/2. Notice that both of these multiplying numbers are still outside the square root area. So, if I am multiplying by 2, let's start with my parent graph in dashed form so I can kind of compare what's going on here. This 2 is outside, which means it is still going to be doing something up and down. So what it's doing is it is stretching the graph up and down 2 times as tall. And this is compared to the origin. So all of these points should be twice as tall away from the origin. So this one stays on the origin, so it doesn't move. This one is 1 away from the origin, so it should be twice as tall, up to 2. This one is 2 away from the origin, so it should be twice as tall, up to 4. And this is 3 away from the origin, so it should be twice as tall, up to 6. So there is my graph. And all of these points are 2 times as tall, because I multiplied by a 2 outside. So as you can probably guess, if I have a 1/2 out here, then all my points should be half as tall. And remember, it's tall because it's outside, so that's vertical. So I'm going to take all these points and make them half as tall. This one's 3 away. Half of 3 is 1.5. So notice it made that whole graph half as tall. So that's your outside. We call this a vertical stretch because it's stretching the graph up and down vertically. We call this a vertical shrink because it is shrinking the graph down vertically. Last melon, inside. Now remember, inside is always going to be inside your function area. So this one needs to be greater than 1. Let's use 2 again. This one needs to be between 0 and 1. Let's use 1/2 again. But you'll notice that both of these multiplying numbers are happening inside the function area, inside the square root. And remember that inside is always side to side. So both of these are going to be a horizontal stretch, stretching horizontally, or a horizontal shrink, shrinking horizontally. And remember, inside is always opposite. So you would think that this is timesing by 2, so it should be twice as wide. But it's opposite. So this is actually going to be 1/2 as wide. We call that a horizontal shrink because it's opposite. So if I draw my parent graph here, I want all these points to be half as wide. So that's comparing this to the y-axis. So I want to bring all these points halfway closer to the y-axis. This one's 4 away, so I want it to be halfway. This one's 9 away, so I want it to be halfway at 4.5. So notice that all these points came in to be half as wide. So this one is multiplying by 1/2, but because it's inside, it's opposite. So these are going to be 2 times as wide. It's wide because it's inside, so that's a horizontal stretch. So I have my parent graph here. And I want to take all these points and make them 2 times as wide. So that's compared to the y-axis. So this is 1 away from the y-axis. So now I'm going to times it by 2. It's going to be 2 away. This is 4 away. So I'm going to times it by 2. It's going to be 8 away. This is on the y-axis. So that one doesn't change. So that is my new graph. And notice all the points are 2 times as wide. Now notice, this is only affecting the x value of these points, not the y value. Okay, that is all of our different types of transformations. In the next video, we're going to start talking about how to apply those transformations to examples.